Before you watch the video, subscribe it, click on the bell icon for more notifications. Hi everybody, welcome to AGAA-MATH. This is Rakesh. Today we are going to see about the geometric progressions, how does it work and where does it work in our real life. Right, first of all I would like to take an example like bouncing the ball. When we bounce the ball, we know it comes from certain height and like this, right, and it reduces its height after every bounce and it reaches to the ground. So here we can observe the height of the bouncing the ball. At certain height it gets reduces. At a fixed height it gets reduces. Even in this condition, so here this is a height and this is a h1, this is a h2, and this is a h3, this is a h4, right? So to study how it reduces its height at what level, so to study this we need geometric progressions. Right? So let us see more then. Okay, well, let me take one more example. That is even there is some examples like in a container there are some bacteria I have, or there are some bacteria observing. So approximately imagine that there are some 200 bacteria in this, and for every minute the bacteria getting doubled. It means 400, and then after 800. So it means it is happening for every hour. So the first hour it is in this. After the first hour it is 400. After the second hour it is like 800. So at the 24th hour, what is its what would be the number of bacteria located in that? So to study all these things, to study at this type of things, we need geometric progressions. That is nothing but geometric sequence. So we have many other examples, but let me first of all come with some observations giving with the numerical values to understand how they are. Here I would like to give some numbers like 2, 4, 6, 2. Let us observe here like 2, 4, 6, 2, 4, 8, 16, 32, 64, so on. And let me observe one more like 3, 5, 15, 5, 75, okay, so on. Okay, so even if you observe here now let me take one more sequence. There is 3 and 15, it is 75, right? Then 25, okay, so on we get. And let me observe few more like 500, 250, and it is 125, so on. If you observe the sequences here which are getting increased in the first sequence, and observe carefully that it is multiplied with 2 and the next value is multiplied with 2, like 2 to 4, 4 to 8, and this is 8 to 16, and 16 to 32, and 32 to 64. Means in this sequence every number is multiplied with 2, right? And you can observe that every number is increased and also the preceding number is multiplied with such a constant value here. Let me observe here 3 5s 15, 15 5 75, so like that. Here it's getting increased. But coming to here, observe that 500 to 250 means what happened here? It is divided by 2. 250 to 125, what happened? Even it is divided by 2, and now again it is divided by 2, so that we get another value. So with this we have to understand the numbers which are formed in this, like every preceding number is formed by multiplying or divided with a constant value. Is such sequence of numbers are said to be geometric progression. Geometric progression, or also called geometric sequence, right? Now let me come with one more example. Observe how do we represent algebraically, how do we represent the terms. The same, let me take the same, like 5, 25, 125, 625, 3125. If you observe that the first is A1, first term is taken as A1, and the second term is A2, third term is A3, and the fourth term is A4, and the fifth term is A5, so on. Here the nth term is indicated with the An, that is the last term we take. So A1 is also nothing that A we can say, so that it is 5, and A2 we got 25. How? What I observe is A1, the first term, is multiplied with certain constant value, that is 5. So A1 is 5 into 5 is 25, and A3, that is A3 is nothing that A2 into, that is 25 into 5, 125. Even more, I would like to elaborate this. A2 is nothing that A1 into 5 into 5, right? Even we get the same, that is 125. Why I would like to represent that in this form? Because if you observe here, let A1 is nothing that A2, A1 is let indicated with A2 is A into R. The constant value which is multiplied is to be taken as a ratio, so that is R. Now A3 means that is A2 into 5, or it is nothing that A1 into 5 into 5. A1 is 5 into 5 into 5, that is 125. It means A1 is nothing that A, and 5 into 5, that is R into R. So that is R square. If you observe more in this, then A4 is nothing that is the fourth term is AR cube. A5, that is the fifth term, is nothing that AR to the power 4. Right? Observe clearly. What do you observe in this? Right? So see that here it is power 4, so R cube. Power 5, R to the power 4. And then A6 is nothing that AR to the power 5. In this case, we can easily understand then what is happening, that it means AN is nothing that AR to the power n minus 1, because 6 means 5 is nothing that I can write as 6 minus 1. 5 is written as 4, like A5 is nothing that AR power 4, it is nothing that as 5 minus 1, right? So similarly Anth is nothing that AR to the power n minus 1. So this is the nth term of GP. So the nth term of GP, that is geometric progression, is AR to the power n minus 1. So this to be understand. In this video we just observed how the nth term is formed, and in the coming videos we will see how to find any term of a GP. So to find any term of a GP, we have to know two things. One is the first term, and another is a ratio. If you know these two things, we can find any term of GP. In the next video, we would like to